Okay, so as we start sound, there are I'll not go in a linear manner as per the book, and the guys who do not have an NCRT, sound is not there in your version of Lakshmi Singh. In my old version, which I had once shared, there you have sound. Otherwise, you have to prefer your school textbook. This textbook does not have sound chapter in it. Okay, so this is a chapter which you will study in grade 8, very preliminary. Only few things you will carry forward from grade 8. Then there will be grade 9, and after grade 9, you will again study it as a part of grade 11, much more in detail. Now, there are various, I mean, if you dive deeper, then this is a very complex topic, actually not that very easy topic. But when you start it at grade 8, it's at a much easier level. Okay, the study of sound is also known as acoustics. The study of sound is also known as acoustics. So later on, when you will be studying sound, you will study it as acoustics. Today, what we do, we would be spending some time to understand some aspects about vibratory motion. Okay, we will first understand vibratory motion. And another name that we give for this is oscillatory motion. Oscillatory motion. So let's first understand the meaning of the word oscillation. A body is said to oscillate if it actually makes a motion across, to and fro, across a central position of it. Okay, so the best way to understand oscillatory motion is the motion of a simple pendulum. So today we will devote a lot of time to understand, because this is the basics of understanding vibratory, or what we call oscillatory motion, simple pendulum. Why the word simple comes? Because in higher classes, not in higher classes, rather in engineering, you'll study about one more. If you study mechanical engineering, you study one more pendulum, which is known as a compound pendulum. So what we study here is known as a simple pendulum. So let's see what comprises of a simple pendulum. It's not only about a pendulum clock, it's about an arrangement. Anything can be a simple pendulum. So let's see what all are the facets of a simple pendulum. So a simple pendulum will have a rigid support, and this support can be from a bar or from a ceiling or from a stand. And from there, we will be having something which is known as a non-stretchable stretch string. Non-stretchable. You can't stretch it. You can't. It does not have elasticity that you can increase its length. Have you understood? However, this should be in its under full tension. It should not be in a loose format. So a non-stretchable and a string under tension, and the string is under tension because we have something out here which is known as the metallic bob. This is known as the metallic bob, right? The weight of the bob actually makes the string get into tension. Ye dheela nahi rahega, it will be in tight form. And the string is supposed to be non-stretchable. It's not elastic that the string will stretch off, right? Now, in the study of simple pendulum, we will also be interested to know something which is known as the length of the pendulum. Not important for your grade now, but the length of the pendulum is always the length till the central position of the bob. That means if you actually see what is the length of the pendulum, it will be the length of the string plus the radius of this bob. This is known as the length of the pendulum. When you go for higher classes or 11, your basics should be clear. So this is known as my length, and we call it the effective length. Effective length. So effective length will always be the length of the string plus the radius of the bob. Okay, so this is my string. And an ideal pendulum, when it will actually oscillate, that is the tick tock motion, there should not be any form of what we call as a friction out at this spot. There should not be any friction at this spot. All people in this world, they have to send all messages when my class goes on. Okay, so this is, have you understood this? A string which cannot be stretched. The string should be in tension, hung with a metallic bob. A metallic bob is like a ball. It has some weight due to which the string is in tension, and the string should not have any friction out here. But in real world, if you ask me, can we have something without a friction? No, there will be a friction out there, right? Now let's see. This is the composition of a simple pendulum. Now, why do we study this simple pendulum? Now, going for my second diagram. So let's say this is my rigid support. Okay. And I go with my right. Now, this is, if the pendulum is at rest, it would be in this position. This position is known as the mean position. Mean position. This is also known as the central position. Both words are correct. Now we need to understand the oscillatory motion. Oscillatory motion means the pendulum will be the pendulum is the entire system. It doesn't mean this is the pendulum. This is the bob. This entire system is known as the pendulum. The pendulum should be in a stretched mode, and in a stretch mode, when it does a motion of this order, that is, it goes across the mean position on the left, then again goes on the mean position on the right. This motion is known as oscillatory motion. Have you got it? So what I will expect the pendulum to come out here and the pendulum to also go on this side, right? This and this. This is called an oscillatory motion. So oscillatory motion means a to and fro motion. A to and fro motion, okay, about the central or mean position of an oscillatory or a vibrating body. Let us slowly try to understand. An oscillatory or a vibrating body. Who is the oscillating or the vibrating body? The pendulum itself is the oscillating or vibratory body. To and fro motion. That means when my pendulum goes on this side, I give it a name called to, right? And when the pendulum again comes back on this side, I call it a fro motion. Have you understood what is to? You can even take this one as to. See, you can even take this side as to, your wish. Then the reverse one is called fro. To and fro. To and fro motion. A to and fro motion is called a oscillatory motion. Now there is many interesting things in this motion itself. If you see the bigger picture, tell me, when something is oscillating in this manner, can you predict its motion? Absolutely. Kabhi yahan, to kabhi yahan, yahan, to kabhi yahan, yahan, to kabhi yahan. I can predict it. That means these also fall in the category of periodic motion. Periodic motion is a motion in which a body repeats its motion after a fixed period. So in a pendulum clock, every 1 second it is coming back. So you know every 1 second it will come back. It's a periodic motion, a repetitive motion. A repetitive motion is a motion which repeats itself after every regular interval. Let's get away from pendulum. Let's see some more example. A child in a swing. That's also periodic motion. Do we call it a periodic motion? Yes. The sun, the earth going around the sun, is it a periodic motion? Yes. Every 365 and 1/4 it will go around the sun. Do we call it a periodic motion? Yes. Advait, pay attention, pay attention. Do we call it a periodic motion? But I don't call it a oscillatory motion. I can't call it an oscillatory motion. Better don't attend class by lying on bed and all. Like, we'll have some respect. I mean, can you not sit on the table and attend classes? What is the issue? Okay. When you're attending on bed, please switch off the camera. I mean, it at least doesn't disturb me. You can switch off the camera, beta. You may be unwell, that's different. But somehow when I teach, it gets me into a very wrong thing. Okay. The moon going around the sun. Sorry, the moon going around the earth. Every 24 hours, there are two motions. The moon is actually spinning on its axis, plus the moon is also going around the earth. These are known as repetitive motion, periodic motion. I don't call it as oscillatory motion. Another way, and one more example. A hacksaw blade being used to cut a piece of iron. Chang, 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 chang. Is it periodic motion? Yes. I know it will come back. Can I call it an oscillatory motion? Yes, it's an oscillatory motion. The body is moving to and fro about a mean position. Do you agree? Okay. Now, so are you able to marry something between periodic and vibratory motion? Every vibratory motion is a periodic motion, but every periodic motion need not be a vibratory motion or need not be an oscillatory motion. When you go in higher classes, you will see another finer version of this, which is known as SHM, simple harmonic motion. Get to know the term. Simple harmonic motions are those in which the displacement has to be so small that it should be like a straight line, but actually it's not possible. See, look at this pendulum. If the pendulum oscillates, you are going to actually make a circle. Do you agree? So when you do this experiment in grade 10 or something, the oscillations cannot be, you cannot take this wide. Like a swing is an oscillatory motion, not a simple harmonic motion. If it was simple harmonic motion, it should be just displaced so that the line, the path it is traversing should be a straight line. Now come back to your hacksaw blade. Simple harmonic motion. Oscillatory motion, simple harmonic motion. Child on a swing is oscillatory motion, but not simple harmonic. But simple harmonic's definition is a little bit more complex. You will get to know that, you know, it has to follow an equation of parabolic equation. Those not at your level. So what did we learn? We learned about something called periodic motion. The fan rotating is a periodic motion. Periodic motion के बहुत सारे type होते हैं. Vibratory motion, simple harmonic motion, oscillatory motion. In this chapter, we are more interested on vibratory and oscillatory motion. The best way to understand this motion is a simple pendulum. I could have also explained this to you in the form of a swing. Yes, is a swing a simple pendulum? Yes, a swing is also a simple pendulum. You can imagine it to be a simple pendulum. Not exactly, but if you tell, is a swing an example of vibratory motion? Yes, it's an example of vibratory motion. Is it an example of oscillatory motion? Yes. Is it an example of simple harmonic motion? Well, no. Can be if the displacements are so small that it is actually making a straight line. Got it? Now in this, let us try to understand some more aspects. Okay. So can you now relate what is a mean position? Can you now relate what is to and fro? The extreme, these positions are known as extreme positions. Extreme position, and this is also known as extreme position. I'll call this as the extreme R and I'll call it as the extreme L. I hope you've understood. One is the extreme left and one is the extreme right. Okay. Okay. Now comes our first definition. We say that the maximum displacement of the oscillating body from its central position to either of the extremes. Okay. Maximum displacement of the maximum displacement kitna dur tak gaya, the maximum displacement of the vibrating body from its central to either extreme, that will be known as its amplitude. Very good. This will be known as the amplitude. So let's take down the amplitude out here. So this is one measurement of amplitude. This is also one measurement of amplitude. On either conditions, we say if one amplitude is positive, we say that the other amplitude is negative. Like if this is negative A, this is positive A. Have we understood amplitude? So our new letter was amplitude. Okay, we'll now change the slide. Amplitude. Can I change this slide now? Okay, and we do some recap and some things. Okay, periodic motion. Periodic motion, a motion that repeats itself after a fixed interval or a time, which is known as its period, is called periodic motion. Okay, you come to my class every weekly. This class happens every day. There's a periodic motion. Okay, so one class of periodic motion is what is known as oscillatory motion. Oscillatory motion is a sort of periodic motion in which the body oscillates around its central position. Tick tock, it oscillates. It undergoes an angular oscillation around its mean position. A special class of oscillatory motion can also be an SHM, which is called a simple harmonic motion. In this case, the amplitude is very small. Amplitude is small, and it should almost be straight line displacement. Okay, but children, am I going to constrain you here? No, we are here. We are allowed to do as much you can do in this chapter. No one allows you. This is more refined. We are not going here. We will be in this chapter in which you are allowed to oscillate as much as you want. Understood? Then in oscillatory motion, we understood a concept which was a simple pendulum. So what is a simple pendulum? A simple pendulum is an arrangement. A simple pendulum is an arrangement which consists of a rigid support, a non-stretchable string, and a metallic bob hung at the end of the string such that the string is under tension. Right? That is a simple pendulum. It's an arrangement. It's an arrangement. Three people make the simple pendulum: the rigid support, the string, and the metallic bob. The simple pendulum is characterized by its effective length, and the effective length is always length of the string plus radius of the bob from the point of suspension to the center of the bob, not only the string. Many people do this mistake in grade 12 practicals also. They'll just take it till the string. No, string plus the radius. So in simple pendulum, we get into another one concept which is known as what is the effective length. So this is also known to you, okay? And if you get a little bit confusion, is the length plus the radius of the bob. The second thing that we learn about here is the mean position. Mean position. How do you categorize the mean position? The position described by the simple pendulum when it is at rest, under no disturbance condition, at rest. Rest में होगा तो थोड़ी एक side में से लटका रहेगा, नहीं ना? It will come down, and at rest it will ultimately come and take its position. That is known as the central position or the mean position. The position described by the simple pendulum when it is at rest. So this is the position at rest. After that, we also got to understand something called extreme position. Extreme position. And an extreme position can be the extreme left and the extreme right. Okay. Then we got to understand something called the amplitude. The amplitude. Amplitude is the maximum displacement. We don't use the word distance, that you'll get to know in grade 9. Maximum displacement from mean position to either of the extreme position. Fine, this is clear now. ठीक है? So in radios, when you see written AM, there's a switch in radios called AM. AM is amplitude modulation. Amplitude is a length, so its unit will always be in meters. Its unit will always be in meters because it's a length, end of the day. Clear? Anything that you have not understood so far? बैठ गया? आगे बढ़े? आइए आगे चलते हैं. Once again, see how many times I am drawing diagram. The more and more you draw, the more your clarity comes. ठीक है. Now, students, see this. Suppose the pendulum is in this position, and in the stretch mode, I have taken it. You can't make it loose. You have to take it in stretch mode, and you have taken it to this position, which is called one extreme position, which I say the position 1, right? And you release the pendulum. Once we release the pendulum will do what? The pendulum will come and go to the extreme right position. This motion is known as my 2 motion. 2. Rather, I'll call it as 1 2. This is 2. एक बार गया ना, so 1 2. Understood? After going here, the pendulum will stop. Gravity works on it, and again it comes back. Okay, so that motion will be known as, will again come here. This will be known as the fro motion. 1 fro. Sir, could you not have started it from this side? Yes, child, I could have started it from this side also. Doesn't matter. You release it from here, then this is 1 2 and 1 fro. Understood? Right. Now imagine when it went from 2, from my house, it went to auntie's house, and in fro, it came back to its house. Something like it completed a cycle. It's like it's completed a cycle. So this is called a cycle. So this is called one cycle of oscillation will comprise 1 2 plus 1 fro. Imagine from its house, it went to uncle's house, from uncle's house again to its house. So this one cycle of oscillation, in other words, will also be known as simply one cycle, is also known as one oscillation. One oscillation. One oscillation is 1 2 and 1 fro. Okay? One oscillation means 1 2 and 1 fro. One cycle means 1 2 and 1 fro. Okay? Done? Okay. Now we introduce a guy out here who is doing this experiment. So we have a guy out here, and he has something which is known as a stopwatch with him. Right? Typically, we should have 2 guys in this. Okay? There should be 2 guys. So this guy is the guy who is performing. So he will hold the bob, and this guy will start the stopwatch, and this guy will say start. And when he starts, this boy is supposed to release the bob. Release the bob. Not throw it. Release the bob. Throwing is not allowed. Throwing means it will acquire some energy. It should go on its own. It releases it. Right? So we now bring a new concept again, and we say that the time taken, the time taken to complete one cycle or one oscillation or 1 2 plus 1 fro, this is known as, या भूल ही नहीं सकते, ये आपको 11 12 engineering तक सताएगा. This is known as the time period. The time period of the earth to complete one cycle is 365 and 1/4 day. Yes or no? And the grandpa clocks that you have in your house, what is the time period? 1 second. In 1 second, it is making one cycle. That's why ting tong, the pendulum is supposed to make half second this side, half second this side. So in 1 second, the pendulum is supposed to make one oscillation. Have you understood? Time taken. Now, how do we calculate this time period? Look, the pendulum is such an interesting thing that the moment you release it, it will go and come back. You won't be able to calculate for one oscillation. So when we do it in laboratory, so that you have the connect for the topic, that's why I said we have 2 persons. And these things should be done practically by children. One will hold the stopwatch and one will release the bob. And say we will take 30 cycles, right? So it goes 1, 2, 3, 4, like 10 you can count. So for 10 cycles, and when 10 happens, stop. And Rayan stops the clock. So the clock actually recorded for how many oscillations? 10 oscillations. Can you find it how for one oscillation? Just divide it. So were you very accurate in your experiments? Maybe not. Repeat it for 3, 4, 5 sets. So we do 5 sets of 10. And then to even make it better, what we do? We take the average. That's the best count. So let's say the time period is 1 second. That means it should do 10 oscillations in 10 seconds. but you will actually find no, it took 10.5 because it's a stopwatch. He might also switch it off. It's all human thing. Stop. He might get a little bit delayed in doing that. So do 10, 10, 10, 10, 10. If once you can do for 10 oscillations, one you can do on 30 oscillations, one you can do for 15 oscillations, repeat, and that's how we do in lab. And then we take an average and we get into time period. So have you understood? So time period ultimately is a measure of time. And so its unit will always be in seconds. Its unit will always be in seconds. Are we fine? Right? So let's do one small mathematics orally, that I have a pendulum or a swing. A maid is swinging a child such that the child is making 300 oscillations in 15 seconds. Now the child will actually puke. 315 is very high. So 300 oscillations, say suppose, in 150 seconds. What is the time period? 300 divided by 150. So 2 is the 2. 300 divided by 152. So every 2 seconds, the child is twing, twing, coming back, twing, twing. 1 second for 2, 1 second. Okay? And this only 2, it will be known as half time period. Half time period is for one side and another half time period. Half time period plus half time period gives you this. Is this clear? The next topic, which people generally get confused. This is known as frequency. Let's not talk about here in terms of this at all. Frequency. Let's talk it in terms of statistics or something. Frequency. What is the frequency of your maid? She visits us twice, once in the morning, once in the afternoon. Once the dishes are soiled. Frequency is how many times does a happening happen? You people show your face to me thrice in a week, and similarly I show my face to you thrice in a week. Our frequency of meeting is 3 times a week if we take week as a time period, right? Similarly, we will say, what is the frequency of seeing a full moon? Well, in a month the frequency of seeing a full moon is once. You'll just see it once every 14 days. Next 14 days it will be a black night. Okay, so it says it's once. एक चीज को कितने बार आप देखते हो? That is known as frequency. Understood? Let's apply that knowledge out here. Time period is the time taken to complete one oscillation. Frequency means how many cycles or oscillations in 1 second. As simple as that. Let's go to the maid example. 1 minute. Let's go to the maid example. That's the example that I gave just now. The maid and the child. I said that they are making how many? They are making 300 cycles or oscillations every 150 seconds. So you calculated the time period as, how do you calculate the time period? This is directly inverse proportion type problem. In 150, I made how much? 300. Therefore, in 1, I will make 300 divided by how much? 150. So 300 or 150. Is this correct? No, this is not correct. This is not correct.
If you check the frequency, then it's...
That's what I wanted to check with you. This is not right. It is not like this. How much time you took to complete one cycle? So how to do this problem? In 150, you took, in 150 seconds, you took to complete how much? 300 cycles took how much? 150. So if you do it in unitary method, you will say it like this. 300 cycles took how much time? 150 seconds. Therefore, one cycle took how much? 150 divided by 300, which is half second. Remember, when you are calculating time period, numerator should always be time, because the answer has to come second, not by second. Are we fine? To complete one cycle, you took how much? Half a second. And are we correct? Yes. half a second. That's why in 120 we are able to do double the number of oscillations. As simple as that. Got it? So the time period for the, who did not understand this thing? Anyone who did not understand? Understood? Time period is the time taken to complete one cycle. The problem, they'll ask you to calculate time period. The problem they'll give you in this manner. Now we go back to frequency. What is frequency? How many oscillations in 1 second? So out here you're saying what? In half second you do one oscillation. But we don't want to measure you in half second. We want to measure you in 1 second. In half second, you do one oscillation. So in 1 second, you will do two oscillations. Therefore, the frequency for this problem, the frequency is 2. This establishes that frequency's formula is very simple. It is 1 over time period. And time period is always 1 over frequency. Just check. What was your time period? Half. Frequency is 1 over time period, 1 over half, 2. And if frequency is given as 2, time period is 1 by 2. Time period and frequency are always reciprocal of one another. Therefore, what should be the unit of frequency? Now look, the unit of frequency would be, how do you say the frequency? I say that I did, for this particular problem, I'll say 2 cycles in 1 second. Is it not what we found out? Can we better it in English? We'll say 2 cycles per second, right? Can we still better it? We say 2 CPS, cycles per second. And this has got a unit which is known as Hertz, in the name of Heinrich Hertz, okay? 2 Hertz. And Hertz is same as second to the power minus 1, because see, time period niche rahega na. Second to the power minus 1 is Hertz. Hertz. So somebody might tell you cycles per second is same as Hertz. 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 For example, I'm just changing the screen. For example, in India, the signal that comes in your house, this is known as alternating current. Later on, you will find this is also a type of oscillatory motion. The current is also a type of oscillatory, alternating current. Okay. And the batteries and all these things, Duracells, they give you direct current. The current is steady. Here, the current is not steady. So in India, the current comes at 240 volts and the frequency is 50 hertz. Means, just imagine, between these two terminals, in 1 second, 50 cycles this alternating current is making. Means 100 times this is positive, 100 times this is negative. 1 negative, 1 positive makes 1 cycle. So actually, if you connect a bulb, the bulb should actually glow and switch off, glow and switch off. It is happening like that. But persistence of vision, we are idiots. We can't make up. They can't see at all. That's why if you actually put, even if you can put an LED on an alternating current, the LED will not glow steadily because LEDs need absolutely steady current. But this is such that before the LED realizes another steady cycle is coming, say 50 cycles in 1 second. Are you imagining? You look at the pendulum. The pendulum is doing 1 cycle in 1 second. It is doing how many? 50. And same thing if you go to US, then the voltage is 110 volt, 60 hertz. 60 cycles in 1 second. So earlier days, all these motors and everything that you have mixies, we call rotations per minute. Rotation per minute. That can also be RPM, RPS, rotations per second. You can also convert it into cycles per second. End of the day, it is frequency. You put Sarvesh here on a merry-go-round, and then he will again turn and come here. Merry-go-round, you keep on coming. So you have a circular frequency. After so much time, I will see my sun again in front of me. Again, I'll see my sun in front. So cycles per second. Okay? So now tell me, what all did we study so far? These 3 things should be clear to you. Amplitude, the maximum displacement of an oscillating body from its mean position to the extreme positions of either left or right, is called amplitude. Amplitude is a length and is always measured in meters. Okay. Then comes the word time period. Time period. Time taken to complete one cycle will always be measured in S, denoted by T. Then comes the word frequency. Frequency tells me, frequency is denoted by F. It tells me this will always be in second minus 1 because this is per second. Or we can also write as hertz, or we can also write CPS. It tells you how many cycles in 1 second. Let's take one problem, okay? Let's take, say suppose you have a speaker. You have a speaker of your headphone and the speaker is vibrating. Now why this was taught with sound? Everything vibrates, it's vibrating. And the speaker's membrane, on the speaker's membrane is something like this. This is my speaker. This is this magnet of the speaker. And say this is the membrane, and this membrane is actually vibrating. So it vibrates, and let's say it is vibrating 480 cycles every, say, 12 seconds. Every 12 seconds is making how many? 480. Okay, so now we have to find out what is the frequency and what is the time period. Let's go by frequency first. We'll try to find out the frequency. How to find out the frequencies? After all, in 1 second, how much? So we go like this. In 12 seconds, you're making how many? 480 cycles or oscillations. Therefore, in 1 second, you'll be making how much? Convert everything to rupees, paisa like this. So many pens cost so many money like that. It's okay. So we will be doing 480 divided by 12. ऊपर में cycles था बेटा, नीचे second आ गया. नीचे second. Right? So it becomes 40 cycles per second, which means 40 seconds inverse, which means 40 hertz. Then they say calculate the time period. The time period T is always given as 1 upon F. Frequency is F, the time period is 1 upon F. So it should be how much? 1 by 40 seconds. Seconds. What happened? No, it should be there. No, it's I'm on it will pick up. I'm actually on what do you call different filter setting. That's why it's showing this one. Okay. So time period. Now, since you've calculated frequency 1 by 40, but let's calculate time period by the crude way. Let's calculate time period by the crude way. How will you calculate time period by the crude way? Time period is how many. No, first come to the basic. How much time I took for one oscillation. So I go like this. For how much? 480 cycles. How much time you took? 12 seconds. For one cycle, you will take how much? 12 by 480 seconds. So this is 1 by 440. You can do this. Then frequency, you can just swap it up. Clear? This concludes our basic about. Yeah, time period is reciprocal is frequency. The formula that we have is T is equal to 1 upon F. Time period is always measured in second, frequency is always measured in hertz. So we took a typical problem where we tried to calculate time period, then you can apply frequency, then you can go to time period. End of the day, ask yourself a question. Whenever you are doing time period, you are supposed to find out one oscillation took how much time. And in frequency, you are supposed to say in 1 second, how much of an oscillation I did. Now, a very interesting question. There is a sort of a pendulum with me in my lab, which does one oscillation in 1 second. What is the time period? 1 second. What is the frequency? 1 hertz. 1 hertz. In 1 second, it does one cycle, and one cycle takes 1 second. So it's a very unique combination where the frequency and time period are same. Time period is 1 second, frequency is 1 hertz. To complete one cycle, if I take 1 second, my time period is 1 second. Now ask yourself, in 1 second, how many oscillations did you do? One oscillation. Okay? This basic is understood. Now we need to see, why do you marry this? Now keep this in mind. We'll again revisit this. Now the question comes, why this in sound? Okay. Now sound.
Because the oscillations create vibration.
Yes. Sound is created by, always remember, for sound to be created, there has to be a vibrating body. A vibrating body. This body can be composed of many small particles or any other thing. Take a cycle bell, start clinging it, and put your hand on that, the bell goes away, right? Everything that vibrates, even if you put your mobile phone on vibratory mode, it's vibrating. So we start with very basic examples, like say, we take string instruments, okay? String instruments. Yeah, string instruments. We take membrane-based instruments, okay? And then you can take air column-based instruments, same. Air column. So let's look at the common thing about this. String instrument, guitar, sitar, whatever you have, your violin or veena. End of the day, what do? We actually will show you something like this, that we have got two rigid support. Even in a guitar, you have got two rigid supports, okay? And between the two rigid support, what is happening? You're plucking the string, so the string vibrates. It goes on a two motion, it goes on a fro motion. Two fro, two fro, two fro, right? Now we come to one more thing. Even in a tabla, there's a membrane. The membrane vibrates. In a speaker also, the membrane vibrates. And in an air column, the air column will create the vibration. Like in flute, or even in the old days piano, not the electronic piano, the old piano. Yeah, strings inside, or even the harmonium. So the air column. Okay. So sound is caused by vibration. A vibrating body can only create sound. This is understood. So here now we apply, what is the role of amplitude? And amplitude is directly proportional to an aspect which we call as loudness. Amplitude square, but these all you will get in higher classes. It's not exactly amplitude square. There will be much more constants, okay? It is related to the square of the amplitude. Now, when you study about wave mechanics, like we are studying in grade 9 now, the last class we had, every wave will have an amplitude. Sound can be represented by wave. Light can also be represented by wave. There, the amplitude will tell you about the intensity of the light. Here you learn about loudness. There you will be learning about the intensity, how bright the light is. Okay. So amplitude is all about loudness. A loud sound always has a loud amplitude. Now, how do you increase amplitude? Increasing the volume of any device. When you increase volume, you are actually increasing loudness. The more volume you are giving, the more the speaker is vibrating. And after some time, you will do too much of atyachar and the speaker membrane hut jayega. It will become like that. It will no more be able to take you. So have you understood the implication of amplitude? But pluck a guitar string slowly, less sound, tongue, more sound. That's called a loud sound. Understood? Okay. Now, the next thing comes is, we need to understand what is the role of something called frequency. Okay. Frequency is related to something which we call as shrillness of sound, shrillness, or the pitch of sound. Okay, the pitch, shrillness or pitch. A baby is supposed to have a frequency much more than the frequency of an adult. If you play music loudly in your house, maximum your flat and two flats above and below you will be affected. In no condition an entire person can hear a loud music from your house. But if a baby wails or cries, don't do that. The lips will become chapped. You're a girl, so Vaseline and a lip balm always, never. I know we love to do that, but slowly you'll see the. Okay, so a baby wailing at night, girls, that scream that you do, that is called shrill. Shrill noise can be heard from very far away. Strike a bell, ding ding ding, like the fire brigade, dang, 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 when it makes that, that's called a shrill sound. So if you compare in human beings, the baby girl, most frequency, followed by the baby boy, then the girl, then the boy, then the lady, and last the gentleman. The gentleman's frequency will be less. more is the frequency. In music system, if we say, if you see in your car stereos and all, you've got two switches called, one is written as the bass, the bass, that will be written as bass, the bass, okay, and then another will be written as treble. The more you increase treble, the more you are increasing frequency. That sound will come, and the more you increase, the bass will come. Bass is low frequency. It can shatter the glass also. It will cause reverberations. You can hear loud bass sound is very dangerous. Okay, so frequency is directly related to the shrillness or the pitch of sound. Is this understood? Now, when you actually go in grade 9, you will see in the form of wave, we show it like this. Say this is a wave. This is a wave showing a sound. This is the frequency. Sorry, this is the amplitude. Okay. Now suppose this is a song being sung. Mary had a little lamb, and somebody singing. Now see this. This is the same song being sung much more louder. The melody will be the same. Mary had a little lamb. And no more interesting. If you actually get a thing like this, it's going like this. The same song with double the frequency. It's making, this is one cycle. In the same time period, it is making 2 cycles. It's 4 cycles. Way it's lower means the frequency is also very low, and the loudness is also very low. Niche. That's why when children sing a song, their playbacks are usually played by ladies. Gents don't play for the playback of even a baby boy in a movie. Now, if you are a little bit versed with the piano, every piano has got a middle C switch in it. Then the next C, this will also give you do re mi. This will also give you do re mi. That will be exactly double the frequency of this. This is exactly double the frequency of this. So if you put a do re mi here and you play half there, ulta ulta ho jayega. Are you understanding? This is in higher classes. Like more frequency means more energy. This is what we show. So is amplitude and loudness understood? Now, the next thing we should also understand is that now this is an instrument which has created a sound to you, right? Which is creating sound. So every sound creating object should be a vibrating object, that we have understood. But here is our person who is going to hear this sound. How does the sound travel from this person, from the object to the person, right? Now, so first thing is, sound always needs what? No, don't say air always. It will always need a medium. It can also be that you put your ears on the railway track and the train is coming, then you don't need air. Or you put your ear on the table, just put your ear on this table and ask Rayan to just scratch with his fingers. Can you hear it? So we are not using air at this case, right? So we are using the solid. The sound needs a medium, and this medium can be solid, it can be liquid, or it can be a gas. Since we have air more as prevalent, so we talk everything in terms of gas. Does not mean that through solids and liquids sound don't travel. Sound travels through solids and liquids also, right? That means if you are in any atmosphere or any place where there is no medium, you can't expect sound to travel. Now people will give you examples about space and all. Forget those. Have you done one notorious or mischievous thing when your mother used to give you a Bournvita in a glass, or once the Bournvita is over, like in my childhood days, I used to enact as Hanuman. Take the Bournvita glass in your mouth like this and suck it inside. And the katura will stuck on you. That time you try to speak and we'll try to hear. We're not here because you have sucked all the air inside. There is no medium, it's vacuum. You can't hear. Why? Because sound needs a medium. That's the easiest way to understand sound needs a medium. So now come that when we go to space and all, you might be in front of me. We have just come out of, say, the International Space Station, both of us. Can we talk to each other? No, we need radio sets at that time. At that time, the communication will always be on radio sets. So sound needs a medium to travel. Is this understood? Generally, our medium is air. So once this vibrates, this creates a vibration on the nearby air particle. And these air particles are very interesting. Imagine lots of kindergarten kids sitting in a Delhi metro type of metro seat. Okay? And you start tickling the first child. And you see the last child is also shaking. Are you actually shaking that child? Not at all. Domino effect. So air particles are like sofa cushions. You should have what in them? You should have something called elasticity in them. As I speak, abhigya. So the air particle right in front of me underwent some sort of a compression. My voice silenced, and then he said, "Why did I compress?" It again expands. As it expands, the nearby has got compressed. See, if you suddenly become fat with a lot of kids sitting, don't the other two kids will? But everybody will become fat and thin in repeated intervals. Are you understanding? So, if say suppose this is the voice which is being spoken, immediately I will find that there will be a zone of compression which is created here. This is what we learn in grade 9. This gets compressed. So obviously the region beside it gets relaxes. And in the very next moment, this fellow, it relaxes and this fellow will compress. So yeah, rarefaction. This is a sort of again a repetitive motion. And then because we will be able to show you only one part of the diagram. So if I try to segregate zones, you will see this is one zone, this is one more zone. So this zone is known as my zone of compression, rarefaction, compression, rarefaction. But this is one shot view. Immediately in the next shot, what will happen? This will become rarefaction. Means if it becomes rarefaction, then obviously the width will increase and this zone will become compression. And again, I will get a rarefaction out here. Continuously, this thing is happening. Have you understood? And this disturbance then propagates and reaches my ear. Why my sister who stays in Delhi must be speaking right now in her house? Why am I unable to hear? The vibrations are coming, but they have died down by the time they are coming to Telangana. Are you understanding? If somewhere we could have amplified. So use the phone, convert her voice into electromagnetic signal and make the electromagnetic signal travel, again decode it by a speaker out here, get it on my ears. The speaker again uses the what? Air column till my ear. I'm hearing my sister here itself. If you shout, you actually have the thrust to vibrate the air particles still there. Therefore, what you do, you try to make it like this. Sunte ho, so that yawa na jaye. Okay? So sound needs a medium to propagate. Today we studied about what causes sound, right? So sound instruments always need a vibration. Tomorrow in our next class, we will see how as human beings we are making sound. Then we will see how does each medium behave with sound. Is air fastest? Is solid fastest? What happens if it is slow? What happens if there is no medium? And then we will see that what is the range of audibility for a person? Do you hear everything? And some more interesting facets. So is this part understood? The numericals you will get from the first part. Second part is all about instruments. Our next topic will be to discuss how human beings produce sound and how sound propagates. We have understood. We will speak about the human ear. पढ़ाया नहीं पढ़ाया हम पढ़ेंगे उसमें क्या है ठीक है ना साइंस कभी कम थोड़ी होता है how sound propagates we know right and if there is no medium then how can you have sound how can you receive sound then you have to bypass the sound mechanism you have to create something which is electromagnetic waves so you have to have radio waves or radio sets no medium no sound can light travel through vacuum yes because light is an electromagnetic wave. Sound is a mechanical wave. So we'll talk a little bit about mechanical waves also in our next class. Okay? Chaliye.